I've been using Unity 3D on and off for the last 10 years or so. Lately I've been moving more and more into Godot, but I have to wonder if there isn't more to life. What if there's something else out there? Maybe I should learn Raylib. Okay, enough horsing around. I'm giving myself a challenge. This weekend, over the course of 48 hours, give or take, I will try to learn Raylib. I started out just staring at an example project, but after my 48 hours were up, I had made a very simple first-person shooter with movement, animations, and enemies that could be destroyed. It's not pretty, but considering the many hours I spent fighting the compiler, trying to learn C, and just learning at the same time, I'm pretty happy with the result. But it's certainly not flashy. So what is Raylib? Raylib is a programming library to enjoy video games programming. No fancy interface, no visual helpers, no tools or editors, just coding in pure Spartan programmer's way. So join me as I learn some Raylib. This is going to be casual and fun. I started out as anyone would, with a big cup of coffee. Then I sat down and read the Raylib examples, the documentation, the cheat sheet, the wiki. Well, at least I skimmed them. I wanted to get started. Just open Raylib, and this is what I have to look through. Well, Raylib.h. Now I do know some C, very little. Oh yeah, here we go, look. Raylib core. Example, basic window. Execute. Okay. Congrats, you created your first window. Hey, challenge completed, I'm done. You created your first window. Fantastic. Now, okay, seriously. This is the header file for the Raylib engine, or the library more like. And this is an example that I can use. Thankfully, I'm still happy at this point, now that I've seen the example window, thinking I can just get started on writing game logic. But it won't be quite that easy. So starting a new fresh project, as I soon find out, is as simple as opening any C file with the notepad that comes with Raylib. But before I have a chance to even try that, I start to wonder what all these CMake files are inside the Raylib folder. And I find this thread when googling about it. How do I begin? How do I even start a new project? And there's this comment right here. Put the cmakeslist.txt and the core basics window.c in a folder, then run cmake. Up and running in 2 seconds. I wanted to create a fresh new project, somewhere else on my computer. I went down a small rabbit hole, trying to understand how the binary was built, and because I was seeing CMake files in different parts of the Raylib folder, I assumed that I needed to build with CMake. Now let me fast forward here and skip this, but just know that I spent a good hour or so reading about CMake and trying to see how I could build my project using it. I ended up making a folder on the desktop called My First Raylib Project, and it will contain everything later on. I removed my previous CMake attempts and started anew, just trying to create a C file in a folder and hoping to link it with the compiler. Raylib.h. Okay, so I'm kind of guessing here. I've seen the gist of it. Okay, so I'm just gonna copy some stuff here. Raylib main, and I think the argument was just void. Not really any autocomplete here. The int screen height equals 0. Temperature int screen width equals 500. Sure. Init window. This seems important. Let's borrow this. Let's go. My first window. Yay. Set the FPS to. Well, my monitor is 144. So main game loop. Yep. So while the window should remain open, draw a white background and some text. Sure. Now, obviously, I can't run it. Executable file. There's no executable. Okay, let's go to my folder and drag in the main C and execute this. Okay. No, this is. Wait, yeah. Wait, yes, it worked. Okay, so you have to. I had to use the the right notepad. That's funny. So now here is my own file. This is a C file in my first Raylib project called main C. Oh, and look, it created an application to run it. Let's remove the light gray text. Instead here, just go. Yeah, I can't draw. I need to dodge the microphone to get past. What happens? There we go. Victory! Victory! We drew our own window, we created our own C file, and we managed to render out a window with text in the ball. Very cool. Now I have this main.c, but I can run this application. It's going to open the command window, so here we can see everything that's happening. And here is my game. This is the first step. Now, I don't really want to use Notepad++. Like, that's cool and all. To get a sense of accomplishment here, I want to customize. I want to set up my own dev environment, you know? I want to use VS Code. So that's what we're doing next. Inside of Raylib, there are examples. So here are the example projects. And out here, there's a projects folder. You can even read the README here. This folder contains Raylib templates for some common IDEs. So this is important. You can see here VS Code, and we see all of this. So I'm actually gonna remove everything I just created from my desktop folder. I'm gonna copy paste this. So now I'm closing this down. So this is my own folder, and this is my workspace. Now I'm gonna open VS Code. Now I'm taking my project, I'm dragging my entire project folder straight into VS Code. Do you want to open it? Yes. Boom. And here's our code, yes. So they have these templates. And here we go. This is the template. So if I hit F5, the terminal process failed to launch. First Raylib does not exist. Well, that sucks. Okay. Now in here we have, let's see what we have first of all. So we have this VS Code. So this is the stuff that I don't actually want to do. We have the launch JSON. The settings JSON, the tasks JSON. This is all important for setting up the compiler and making everything work. You know, you can see the Raylib paths here. I might need to replace some of this stuff. And here's the make file. Define compiler path on Windows. See Raylib. Yes, this is correct. Raylib installation path. Okay, so I think this is quite the file that we need to look through. This is the part where I had to look at my first tutorial. I wanted to use VS Code, but I had already spent a lot of time to get this far, and an hour or so wasted on reading about CMake. So I found this Andrew Hamill guy, who made a video specifically about setting up VS Code, and with that help, I could go on to do it myself. So I'm not gonna show all of this. Just know that I spent another hour or so reading through all of this. Okay, so I've been looking around here for ever. I think, so this looks like a command and then the path, but I think we need to add the path c:\raylib. Let's go back to main, F5, please. Oh, yes! Finally, wow, look. Woo! That took way too long. Oh, that took way too long. So the problem was this path. When you get Raylib, there's an entire dev kit here for working on 64-bit version of Windows. And as you can see here, when the project was still, if I just started this as it is, it might have worked. But because I moved it, I needed to update this path. That took me, so many searches. I had to look around the web for so long. Thank God. Now it's running. Now I can't run the task. I need to run from main. Let's do that again just to make sure I didn't mess it up. Yeah, look. Boom. Okay, finally I can start making changes to this project. So, so this is different from the first example. The first example was just text. But here we can see this is actually, this is in 3D. So we can see here that it sets up a camera. I'm glad that exists. And a cube position. Vector 3, so it's currently set to 0, 0, 0. I'm guessing this is the same. Cube position, can I go to that definition? Here we go, here's the struct. Yeah, obviously it's exactly what you'd expect. So here's the Raylib.h, so this is the entire library. This is everything we can use. Here are all the colors that we can use. You can see they're defined as a simple word. Very cool. Here are all the vectors, rectangles, images, textures, everything is in here. This is everything, basically everything that we can use. There's a lot. We just want to change some stuff. So I'm guessing this is a vector and I'm gonna change the value here to 10. Will that even show up? Will we notice? I'm not sure. it's gone. So I'm guessing if I change that back to 0, save, run, or did I change something else? Okay. So is this measuring meters or pixels? It has to be meters now, right? Like units of length. Yeah. 1. It's now standing on top of the grid as opposed to in the middle of it. Cool. Here's the main entry point. Setting the screen width. Let's increase this because my monitors are 2K. Let's go 1280 by 720p. Raylib. Here we see the camera being set. So let's increase the distance a little bit. Let's change the FOV to 80. Target FPS 144, of course. Actually, just change the comment. So update draw. Oh, I like this. They're using it's not all in here. So I'm going to be using this as a basis for my project. This is the basis for my stuff. Right, I'm done. I don't want to set up another environment. Okay, update draw frame. So everything currently happening in the game loop is happening here. And we are calling update camera, which is our camera age, update camera. Okay, so we are simply calling this the camera orbital, which is also, oh, here we go, look at this. There are different types of cameras predefined, and we're calling the update camera in the rCamera.age header. Get mouse delta, move in world plane, mode, first person, third camera. Okay, so a bunch of stuff here for change, but look at this. Is this predefined? Can I just change the camera by myself? That's pretty cool. So it's updating the camera with some built-in function. It draws a white background. Now we did see the colors over here. So I'm pressing F12 to move into, let's change the color to something nicer. Let's go, let's see, maroon. Sounds pretty cool. So I'm going to change the background color to maroon. Begin mode 3D. What does that mean? Begin mode 3D. Begin 3D mode with custom camera. Okay. Draw cube at the cube position, which we defined up here in the beginning. So it's drawing the cube. Draw cube wires. Cube wires and the grid. Maroon. Oh, it's the same. Wait, I didn't know that. Let's go white. Draw grid. Is this the size or is this the resolution? Draw grid, slice, spacing. Okay, so each grid part is 1 meter and it's 10 big, I'm guessing. This is a Raylib example, dark gray. Okay, let's run this again. So I want to see what exactly is doing what here. Oh my god, this is maroon. Beautiful. The window is now a little bit larger. We're also further away from the camera. It's running at 144 FPS. That's the target FPS, so we're not hard locking ourselves. It's just a target. Here's the text. And yeah, cool. We're drawing a box and let's see, can I adjust? No, so the input that we saw in the camera class doesn't work. I'm clicking the keyboard right now. Seeing as this is already 3D, I'm supposed we're making a 3D. Yeah, we're making 3D. Let's not have maroon to start off. Is there no dark green? Yes, there is. Okay, perfect. I think dark green would do nice. Yes. Wow, beautiful. And this text should be white. This is a game made by for you. Now, of course, changing text stuff and colors, like, we're not really learning anything, but we are. We're exploring. You start by updating, like changing values, you know? That's how you start. That's how you start. You start changing values. Draw FPS. Now what's down here? End mode 3D. Draw text. Oh, that's probably super important, right? This is being drawn by the camera in 3D. This, so end mode 3D, this is 2D. This is happening afterwards. This is drawing straight on the screen. You can see the values there. I'm guessing these are offset values. Yeah, the position X, the position Y, the font size, etc., etc. So let's change the font size a little bit to 26. Then we have draw FPS here, text drawing function. Let's look at that. Position, okay. Good FPS. Lime, cool. Get FPS. If FPS is less than 3, changes to orange, changes to red. Okay, cool, cool. Draw text, text format. FPS with the FPS value. This is some type of formatting thing, I'm not sure. Position X, position Y. color. Okay, cool. I understand. This is the position of the text. So we could change this to be on the right side, on the top right instead. So we have this value, which tells us how large the window is. And when we draw a window, and this is true for most editors, I believe, or maybe it's a Windows thing. I'm not sure. We're drawing from the top left corner out into the world, right? So this FPS text right here, 1010, is moving it 10 pixels from the left and 10 pixels down from the top, which is why we're seeing it in the top left corner. This is what we got so far, so change some text, move the FPS counter over here. Can't seem to change the color on that, which is annoying, but hey, it's the first step. We've made the first modifications to our Raylib game being compiled in VS Code. That's a good start. So now that we have the project kind of working, so it's not everything is properly set up, probably, but it's working. Now is going to be a pretty good time to add a repository. Just select this folder, desktop, my first Raylib project. And if I go to history, here we can see all of my files. But all of the settings and everything I've changed so far is still here. The make file is here, the main C file is here, and publish this. So now I can track my changes, and that's super important. So now if I change something here, let's set this to 60 for whatever reason. I can now see I've made this change. If you're not using version control, for God's sake, man, use version control. Track your changes. Let's change this. Camera orbital. Camera or the graphic. First person. Does that just work? Can I just try that? What happens? What? Well, look. First person camera, I can move around. Dude, we're creating Quake. We're gonna create Quake. Or Doom. Okay. We can control the camera like a first person camera. Position. I changed the target to be the same as the cube, which is 010. This is 010. Camera up is up in the world. FOV is 80. Our position, though, should also be 1. And I want to do another thing that I saw. Disable cursor. So if I hit F5 now, maybe, because this is in the main, we'll see. Yeah. Okay, so, because I kept getting the cursor out of bounds of the screen. But now I'm in the game, I can look up, I can look down, I can look around, and the mouse is tied to the window. If I press escape, I turn off the application. So we start over here, we're looking at the cube. You can see the FPS is 144. Now I can't jump or anything. And here is where I get my first recording error. It was inevitable. I moved the previous follow new title down to the left corner. And I also draw a small red rectangle to symbolize health. We are now actually going for an FPS type game. I also want to make it easier to draw these cubes, so I make my first attempt at a function with this draw me a cube function, which simply draws a cube and a wireframe cube on top. Now I can call this function in the drawing step to display cubes. That works. Okay, so I can write my own values. Not sure how that's supposed to work, but yeah, now we have a box over here. Okay, so just draw a couple of cubes here. And yeah, they're all in a line. We have a bunch of cubes. I found this text format function, which turns data into readable text, essentially. It returns a string. And now I copy-pasted this formatting because, I would not have figured this out myself. But this allows me to read the camera's position in the world and draw it on the screen. So if I hit F5 right now, you can see that I can track the player's position, or the camera's position really. So I'm tracking our position, which is pretty cool. So I can see where we are. I want to see if we can implement jumping and gravity. So this function updates the position of the camera. I can see that happening. So we have the camera. We're not tracking its velocity. So before I get to jumping and gravity and all of that, I want to track my player's movements. With the position of our player now showing, I go on to try and track the velocity. This should be as simple as comparing our current position against our last known position from the frame before. So I create a vector 3, camera velocity, and the camera position. Now every frame I set the velocity to our position minus our last position. I also decide to include ray math here, as it has some useful shorthands for writing vectors, such as vector 3,0 and vector 3,1. I end up not using those much, but they are handy. So I end up setting the velocity to the subtraction between current position and last position, and then we update the last position to be the current position, allowing us to do this again the next frame. Next, I simply copy the previous text I was using for the position and do the same for our new velocity. I create the input reading for the space key, and I set the camera's position to increase by 1 whenever it's pressed, just to see that it works. I then create a jump speed and gravity variable. Jumping by moving up 1 step is fine, but we need to also decrease our Y position over time. This should be as simple as decreasing our camera's Y position by frame time multiplied by our gravity value. And of course the gravity is set to negative 9.81. I then create a floor level variable that I don't ever want to fall past, and make sure that we never go below this height. And obviously I made some mistakes, because now we're flying into the sky. After some quick adjustments, we now move up by our jump speed value and then fall down slowly, just as I had hoped. I tried to create something like a jump duration here, but I end up leaving it as it is. And I will come back to this later. Right now I'm just happy I can jump at all. Let's create a new function here called player control. There we go, player control. So in the main game loop, we control the player and then we draw stuff. Player control is just this. I suppose we could update the camera and all of that stuff also in the player control, because it's not really related to drawing. So update draw frame now draws. So let's take all this stuff. Let's extract this to a function and call it build level. Thank you. And let's get rid of this. Okay, we're cleaning up. Everything is good. We control the player, apply gravity and stuff, and we draw. So player control right now measures the camera's velocity, it updates the camera position, it makes us fall, and then we can jump. Well, almost jump. And I want to change this to clamp. Actually, did I still have the... Here's the cheat sheet. Let's go clamp. I want to read the clamp. Float clamp. Value, minimum, maximum. Yes, I like that. Does that mean I could go camera dot position dot y equals clamp camera dot position dot y, and we go 1.7. Now I'm duplicating information, shouldn't be, and 999, like so. Does that do the same? Let's see if this works. Yes, it does. Okay, that's much cleaner. Let's move this. Let's just write gravity here. Makes a lot of sense. Floor. Oh, I like that. Much cleaner. And then here we have the jump. Jump. And then in the update draw frame, so this happens every frame, and this happens every frame. It draws a green background. It then builds the level, and then in 2D, so we can actually go 3D, and then down here, everything past this point is 2D. This is the UI, basically. We're drawing text, and then it ends the drawing. Here's the build level function, which creates all our geometry. And this is a helper function to draw cubes. Not sure if that needs to be static, but whatever. And if we play one last time, just to make sure I didn't mess anything up, we have a constant height. We can look at these boxes, we can walk through them, and we can jump and fall. Pretty good, pretty good. Let's stop there. Let's drink some coffee. I need it. So, I'm back after a short break. I'm currently looking at this example. So this is an example from the Raylib homepage, and it's a selection script. We can click in the scene, or I can click the box to select. I can select, I can unselect, I can select, I can unselect. Cool. So obviously we have collision and raycasting here, which we need and want. You can see here he sets up his cube and its position. He creates a raycast and a raycast collision, And then down in the code, here we go. If mouse button pressed, mouse button left. And now ignore this flag. Ray equals get screen to world ray. Get mouse position, camera. So that's simple enough. And then he does this. So he sets the collision to be a collision box between the ray and, again, this is C. There are no objects. Objects don't exist. So what he does here is he basically creates a bounding box on top of the cube as he's checking for it. That's how I read this anyway. And then he sets this flag, he actually sets it manually, so that we can toggle on or off, basically, right? So if we look at the game again, it's on, it's off, it's on, it's off. Down here in the drawing part, if it's been hit, he draws, so he's drawing the cube and the wireframe. But if it's not hit, so if it's toggled, he draws a gray cube. So he draws a red cube if it's selected, and he draws a gray cube if it's not selected. There is no persistent cube in this scene. He's just drawing a cube. I think this is funny because I'm so used to object-oriented programming. I find it funny that there is no cube. He's just drawing, like a cube is being drawn every frame. Here he's doing a red one, and here he's drawing a gray one. He's also drawing a ray, like a debug thing, so we can see the ray, but we can't see it. So when I click my mouse, it creates a bounding box and sets a flag on or off. But it works, right? So I'm gonna try to copy this. Now I don't want to create a selection script, but I want to raycast out into the scene. And I want to debug like this. I want to see the ray if I can. That's my mission for right now. So I also want to create collision cubes on top of all of my cubes, right, on my level. So we're gonna start off here, and we're gonna create a new little section here. We're gonna go ray, shoot ray, maybe? And then he declared it as 0. And if we look at ray, here's the struct. It's a position and a direction. Yeah, simple enough. Here's the collision struct. Hit, distance, point, normal. You know, the stuff we'd expect. There's the bounding box as well. Yeah. So this is what we need to create collisions, basically. We need to create these bounding boxes. So we create a ray, and then we need a collision. So create ray collision, hit collision, I'm gonna call it. Go 0. So I'm basically just gonna copy his code here, more or less. So let's go down to the camera control, and let's go raycast. I'm a little lazier, but I'm gonna copy paste this. And then we can remove this part, because we're not setting that flag. I call this hit collision, I believe. Shoot ray, I think. Okay, yeah. Shoot ray equals get screen to world ray. Let's create a bounding box. Bounding box equals, let's just compare it against the box. Like so. So the box is empty right now. And why doesn't this work? A value of type integer cannot be assigned to an entity of type array. Yikes. Okay, hang on. I think I found something. Shoot ray equals mouse ray. Aha! Vector 2 mouse position. Okay, so this is what I need. Get mouse ray. Shoot ray equals get mouse ray, get mouse position. And then we set a bounding box, which is empty. Hit collision between those two. This is empty. All of it is empty. And now I want to see the raycast if we can. So draw ray, shoot ray. Color something that will show, I guess black. I'm guessing it's gonna have a length of 1 or something, so we'll see. I pressed left click, and I don't think anything is happening. Nothing is happening. Well, that's unfortunate. I'm going to define a bounding box of some size, just so we have one. It's called box. I think this is correct. This looks correct. So we can get rid of the bounding box here. So we define the box here, then we check against the box. Okay, then I can ask, so let's get rid of all this stuff. If hit collision dot hit. But this only happens for 1 frame. This is only going to happen for 1 frame. Yeah, that's probably the problem. It only shows for 1. Hang on. Here's the ray. Let's also create a bool. Show ray equals false. And if we press the button, if I press the button, then show ray equals not show ray. So we're toggling its behavior. I then create a bounding box and I do a ray between the position, the camera, and towards this box, which exists in the center of the scene. If it hits, then nothing right now, I just want to see it. And in the draw frame, if show array, then draw array. So that should be a toggle now, right? So it's toggling, show or show not. Is it currently too short? Maybe. Because I'm not seeing a ray here. I just want to see the ray, you know? I feel like if I press the button, shoot ray equals get mouse ray, get position, camera. This should be an infinitely long raycast, traveling from the camera all the way down. If I click the mouse button right now, we can see the raycast text pop up. So this is just toggled by me clicking the mouse. I want to tie this to the ray somehow, so I can determine that yes, I've raycasted. We have this bounding box. Bounding box, minimum, maximum. This is the box corner. So it goes from -1 to 1. So this is a box of size 2, I think. Increase the size by just increasing the corners. Let's turn this to 0, 0, and it's 2 and 2. So this should be a fairly large box. It should be 4, right? If I'm not stupid, this should be 4. So if I click, now nothing happens. If I click here, aha! Well, hang on. I got it, wait. No raycast. There, raycast. I hit something. I missed. Hit, miss. No, hit, miss. Obviously I can't. Okay, I need to see I need to see the box. I have to be able to see this. Let's copy this. Let's see, draw me a cube. What? Wait, draw bounding box. Box. Hang on. There's a draw bounding box function. Let's draw it in black. Oh yeah, I can just draw the box. Beautiful. Let's see how that looks. Let's see how that looks. There it is. Yes. Like I said, it's 4. But weirdly, I miss raycast. And I raycast here as well. But this is a miss. Why? Wait, I'm not... Is this... Let me guess. Wait, I have an idea. I think I know what's happening. Disable cursor. Let's save and try that again. Okay, here we are. Oh, this is annoying. Okay. I click up here, nothing happens, nothing happens, nothing happens. I click in the box, raycast, yes. Click in the box here, click in the box here, raycast, no, raycast, no, raycast, no. So this works. It's not drawing the ray. Still, there should be a ray between my last position. But here we go, raycasting is working. I can raycast now. The problem is that I don't want to see the cursor. Raycast miss, raycast miss. Why is it not drawing the raycast? I'm asking it to. That's weird. So down here, in the drawing function somewhere, here we go. Yeah, down here, draw ray, shoot ray black. I'm guessing shoot ray disappears as soon as I stop. Like it only exists for a frame. I'm guessing. Yeah, that must be it. Okay, but we can confirm that raycasting does indeed work. We have raycasting. The problem is raycasting when the mouse is disabled. I want the cursor to be disabled, right? I don't want to see the cursor. So I can't use the cursor when we're raycasting here. We can't use get mouse position because that doesn't make any sense. We need to raycast from the center of the screen. This is a vector too. So if we go, this struct always gives me problems. Vector 2, and then we'll do the brackets. Screen width divided by 2. Screen height divided by 2. How will that work? Will that work? Get mouse ray. It's weird to have mouse ray. Okay. Nothing. Raycast. Okay. Yeah. So even though the cursor is disabled, it was still moving around in the screen, which is why it was so weird. Now we're raycasting from the center of the screen, and we can tell when we hit something. It's pretty cool. Good shit. To make that more clear, let's create a vector 2. Center of screen. Just do this, right? And we go like so. But I want to see the ray itself. I'm gonna try something here. Now this is just guesswork. I'm gonna create a vector 3, shoot line start. Here we go. Vector 3, shoot line end. Why do I write shove? That doesn't make any sense. Shoot line start, shoot line end. And here we go. If we hit something, then shoot line start equals dot position. Shoot hit collision dot point. Like so. If we miss, we set these to vector 3, 0. And if show ray line, yes, draw line 3D, I suppose. From the shoot line start to the shoot line end. Color dot, oh, let's go white again. Let's try that. So I'm just guessing here again. But clicking does nothing. But if I click here, it's not rendering a line. God damn it. Why not? Can I just not see it? Pretty sure it's happening though. If show ray, draw line 3D. Oh, I guess that's not working. But we got raycast anyway. I'll have to get back to, I'll have to do some research and come back. But we can determine that we've raycasted and hit a target. Good start. Alright, so I'm back. I just had to go and eat and take a break. It's been a few hours. I've made several changes without recording. I just had to sit for a while. So if I open the project folder, it now looks a little bit different. Ignore this folder, it doesn't want to disappear. We now have an assets folder. And in the assets folder, I have a sound and a sprite. Now this is a crosshair, courtesy of Kenny, because he's the best. We also have a main.h out here, but hey, we'll get to it. So looking at the code now, it's a bit different. Most of our fields are gone. You can see I just recently committed here. And we now have main.c and main.h. I'm not sure if someone would agree with me that this is a good idea, but hey, it works, so I'm happy. The idea behind the .c file and a header file is that you can move the data to the header file and keep the logic in the C file. You shouldn't always do this. I think I'm not a professional. This is my first time writing C code. But I moved most of my data in here, and here are all my functions. All of them, there aren't really that many. So what's changed since last time I showed something is obviously we have the sound and the crosshair. We also have some shooting mechanics, some bullet line max duration and stuff. And here we have some system stuff. Okay, let me just play. Let's just show you. It's not very different, it's just a little bit different. So the world is still green, we still have these silly cubes, and we have this black bounding box. So I can now shoot. I have a crosshair, and I can shoot. Now, it's kind of hard to tell, I'm not sure if this is going to pick up on the recording, but if I shoot and step to the left, you can see a line here. So it's actually drawing a line from the camera to where I hit. Now this line decays after 0.75 seconds, I think. That's nice. So we can now shoot. We have a crosshair, we can fire. It draws a line to where we hit. That's really the only change. The jump is still like this, it's not perfect. Back in the main class. I've rearranged, I refactored a little bit, it's still all here. These still have to be here, they want to be here. They throw errors if I move them, so they get to remain. Looking at the main, we initialize the window, we initialize the audio device, and we call the initialize player function. Taking a look at that, pressing F12, you can see that we do the camera setup just as we did before. We also load in or preload our texture and our sound. We then disable the cursor so we don't have to see it, and we set the target FPS just as before. Here's the initialize player, here's the update player script. So this runs every frame. We call the update camera, this is the built-in function that controls the camera. We track our velocity, our position. This is the decay function. So the line that we drew when we fired decays every frame. So you can see it, duration is subtracted with the frame time every frame, but it's also clamped, so we can't go minus 500 if we're not shooting. The camera is constantly falling, but it's also being clamped to the floor, so it's good. Here we jump, and here we raycast. So this part, we played the bang sound, we draw this bounding box, which is the box in the middle that we can actually shoot at. And we calculate the center of the screen, we get a ray, we read a collision between us and the box, and if it hits, we set the lines between us and the collision point. So if we don't hit the box, no line is drawn, or rather, the line is drawn. The only way that the line is drawn is by setting the bullet line duration to something above 0. If this is not 0, the line is drawn. This just sets new points. We can actually try to remove this, I just realized. Let's comment that out and see where the line end is if we're not hitting anything. That's interesting, I haven't even thought of that. Oh yeah, look. So this just gets the ray, reads the collision, sets the data, blah blah blah. Here's the draw update. We call the begin drawing, which is a built-in function which sets up the canvas and stuff. Set the background color to green. We build our level. And if the line duration is larger than 0, we draw the line. Because it decays in the player update, this will sometimes be 0 when we're not shooting, and the line will not be drawn. And down here, we draw the text on the screen, we draw the health bar, which currently is not really health bar, but And what's really the only thing that's new here is this. We're drawing the crosshair. Now, excuse all of these magic numbers. We're placing the crosshair in the middle point, as you can see here, screen width divided by 2, screen height divided by 2, and then I offset the texture size as well. The texture is 128 by 128, and I decided to just hard code it. We can change that later. I can use crosshair.width, whatever, right now that's fine. Here we build the levels, we're just drawing some cubes, and here we're also drawing the bounding box that we can shoot. So this does not a collider make, this just shows us the box that we can hit. And here's the function for drawing cubes in the scene. So not much has changed since last time. Let's consider this a checkpoint of sorts. But everything works now. We can fire, we can draw a line, we can jump, all the things we've been building towards is now implemented. This took me a few hours as well. So I need to figure out what else I want to make and how I want to get there. So what do I want to make now? How do I get there? Reasonably right now, we need something to shoot, is what I'm thinking. We could improve the jump. That's the only thing that's kind of messed up right now. And also the collision, we can collide with the boxes, but that seems like a whole ordeal. Same with the enemy though, because how do we track an enemy when we can't make objects? So we need to define enemies. We might need to create like a factory for spawning enemies, but how do we track? There are no objects, I'm not sure. So we want to fix the jump, we want to implement some enemies or something else, something to shoot. This is what the game looks like now. We can shoot, we have a working animation, it's working through some sprite frames, so a line is being drawn from where we shoot, and the weapon is now animated. There's also a cooldown, so I can only fire, I'm not sure if you can hear me clicking, but I can only fire once every second or so. The animation, I believe, takes 0.4 seconds, something like that. Jump is still messed up, cannot collide. This is just a random billboard I placed. The weapon is a billboard, so it's kind of making a Doom-ish clone here. But this has taken a long time. This has taken me hours at this point. It is nighttime right now. The entire first day has already gone, and the reason it's taken so long is it's beginning to show that I am not comfortable working in the C language. I am fighting with the language at this point. my brain wants to make and manage objects. I want to instantiate objects, but that's not really how this works. And I'm having so much trouble with it. So anyway, I think the only thing that changed since last time I showed the project is the animation. That's probably the only thing. We're calling this animate weapon one shot. And there's a flag called, should we animate the weapon? So pressing the button sets this to true. If it's true, this is called every frame. We decrease the frame time from the animation timer. If it ever reaches 0, wait a second, how does this actually play the animation, you may wonder? It's all in the animation timer float here. This is the code for actually drawing the sprite. And this took me a while. Well, this took me a good while to understand. So Draw Texture Pro allows me to draw and animate from a sprite sheet. You have to use this function, or it's the recommended function to use. I'm calling the sprite sheet, and then you have to declare 2 rectangles called the source and the size. And then you have various, like you can see here, image size, which is 256, and then screen height minus and plus, and then vector. This all has to do with the sprite sheet. So if we go up and look at it, here's the sprite sheet. You can tell that there are 4 images. Each image is 256 pixels. You can imagine a blue border here. Well, it doesn't have to be blue, of course. Imagine a border here. That's 256 pixels. So in order to display these images, we need to declare a rectangle from this corner down to this corner. So a start and a stop, basically. And then we need to move that entire rectangle to the right one whole step. And then to the right again, and then to the right again. And then when we reach this, we need to come all the way back around to 0. I'm getting tired. You can tell, so this class is now 200-ish lines, and I tried offloading. I mean, this took me a while, but it wasn't that bad. It got bad when I started fighting with creating more files. So this is the weapon.h. This is the weapon header. And it's a mix right now, as you can tell. I have some defines, some externs, some ordinary fields, and I have a struct. Because I've tried to implement each one at some point and then wasn't sure how to, it's spaghetti. I need to get back to this tomorrow. This is turning into spaghetti, and I need to clean it up, or making any further progress is gonna be hard. I had a bunch of errors, lots of errors, that I just wasn't sure how to fix, and it's taking so long. So I'm done for tonight. The first day has passed. I need to go to sleep, and I'll pick this back up tomorrow with a very big cup of coffee.
C, a statically typed procedural programming language famous for making the world go round.
Alright, it's the second day. I recently woke up after a good night's sleep. I'm back, starting today with some research. I'm reading up, and I've come to the conclusion, or when I say research, I mean I did 10 minutes of Googling, but I came to the conclusion, based on my own suspicion, and from what I read, I don't think I can avoid having a large main. The main.c will have a lot of code in it. That's just how it is. I think that the main will be large. So what I can do and what I should do is kind of what I started yesterday in making these structs. So I want to not necessarily move all of my variables here because, they need to be defined here as well. Anyway, I want to be making these structs to tie that data together. So yeah, I'm gonna take a few minutes to clean this up because I left it in a terrible state. Right now the level just consists of a few boxes, and this is what that looks like. Instead of just drawing a cube every frame, we could create a struct of a cube with a position and a size and a color and with a bounding box so that we can shoot at it. Or maybe even collide with it. I'm not sure about the collision yet. It seems like we need to check against the bounding box each frame. And in the shoot script, I also need to check against the bounding box every time. You can see here, hit collision, get collision box between the ray and the box. So if I have 20, 30, 50 boxes in my script, I'll need to create a loop here and loop through this for every box in my level. And if that's the way to go about it, then that's gonna get pretty expensive. I need to be careful with that. So we might not be able to do the collisions as I had hoped. We're not creating Quake, probably, I'm sorry. Let's see if we can get the weapon working, add some structs, add some more geometry, and fix the jump so that the jump is working as it should, as one would expect. Okay, so I'm gonna fix the jumping now, and I kind of realize that I've already implemented the exact same kind of mechanics several times at this point. So just like the weapon cooldown is diminished every frame, or how the line duration is diminished every frame, I want to do the same for the jump, right? So right now I set the camera position up by some number, but I actually want to increase it over time. We add gravity over time and we climb to the floor. Now I want to add another variable here, which is called jump force or something. So we're always adding jump force, but jump force also decreases over time. So when we press the key, we set the jump force to some value, but that then diminishes every frame. Now I probably want to create a player class at this point, or a player struct, I think. Let's do that. Let's create a player.h. And by now I know that the player.h needs to have a include guard. That should work. I'm starting to learn. So here we can put our logic now. So we want to define struct. So the player has a lot of stuff to it right now, obviously, but the weapon is separate. Most of the shooting is still just here. But in the init player, I do set some things. Like the gun, for example, the camera position. I do know that the player needs some float jump force. We'll start with this, and then in the main I need to include. So include player.h. The player is now struct. To have access to ourselves, then we have the gun. No, I want that to have a big P. Player. No, identifier player is undefined. Undefined. Oh, it needed to be at the bottom. It has to be at the bottom. Now we have a player, and the player only has jump. That's fine. So we have a gun, we have a player. This is much nicer, of course. And then in the init player, we'll initialize ourselves. So you can see, let's move this a little bit. Setting up the sound, setting up the sprite. Player.jump force equals, I don't know what a good value will be. Let's go 5. And we'll create a new float. Vertical force, let's say. So we have a vertical force that's going to be applied to the player. In the update player, you can see that the camera position is affected by gravity over time. It should also be affected by camera.position.y minus equals. Oh shit, boy! Well, I'm flying. Well, that's unfortunate. Okay, so if I press space, we go into fly mode, but we did not teleport, which is good. Vertical force decreases over time. So why do I go flying? I suppose I should clamp it. I'll clamp it between 0 and 999. Vertical force equals clamp. We want to clamp the vertical force between 0 and some high value. Probably the player max jump. There we go. So it's never stronger than the jump force. It also decreases over time. We set the jump force to something like 16, and we make sure to subtract, or like make the jumping decay faster by a multiple. So that way we should still reach the number 16. Or sorry, we are at 16, it's just decaying faster, giving us a snappier jump. Yeah, look at this. Boing, boing. That's pretty good actually. Can jump over this. I can jump over. Cool, cool. Could be even snappier. Let's do this correctly right away. Float jump decay. Set that up here. So player.jump decay equals, let's go 20. And here, player dot jump decay. So now our jump decays very quickly. Ah, look at that. Wow. Here we go. We're jumping so fast. Now, of course, we can never, there's no floor, and we can never go beyond this level. We're just clamped to this value. That actually feels pretty good. It's a pretty good jump. Now we can increase the force. So let's double that to 32 to get a really high jump. But since the decay value is high, we'll also fall pretty fast, making it pretty snappy. Oh, okay. It's a bit much. It's about finding a balance between these two values. It's still a bit much. It was 16. Let's go 20 then. That's a pretty good jump. I actually, wait, hang on. Yeah, look, I've made this sound before. This is a jump sound I made probably 50 years ago. We're gonna use that, so that will be the jump sound. Okay, I've dragged in the jump. And we'll need to preload that. Player.jumpSound equals. So unfortunately this is a WAV file. So we typically want to do with og vorbis, og. And then we want to play that sound when we jump. So obviously when you press the button, play sound, jump sound. That's how easy it is. Boom. Hell yeah. Yes! Alright, so I've just taken some time to clean up the main header. Now, it probably shouldn't be called main header, but one thing at a time. So all the player stuff has now been moved to the player. So you can see our struct here for the player. While I did that, I was browsing through the examples. And I came upon two of them that I thought were interesting. I was in here because I thought, hey, I need a 3D model for enemies. But I figured, hey, I don't have time to create a 3D model for an enemy. I certainly don't have time to animate it. And I saw this. So my backup idea was to create a billboard weapons target. Like an archery target, you know? But this already exists in the engine. So here, this is inside the Raylib folder. All of the examples are in here. They're shipped with the engine. Examples, models, resources. The billboard is right here. So I can just add this and use it as an enemy. Perfect. So they won't be moving or anything, but hey, we gotta start somewhere. And then you also see this texture atlas here for a cube. This is part of another example. You can see that they're using the same thing for this maze over here. They're all using the same texture. Now, I could do this and just kind of copy paste, but that feels incredibly boring. I might take a look at how they've done it, how they've set it up, because they're loading. Oh, it's a 3D model that already exists. Okay, I'm gonna use this billboard, and I am going to try and make my cubes look like this. I think that'd be cool. So let's grab both of these. So I'll just copy both of those to the assets folder. I'll create a new file here called enemy.h. The enemy.h needs a include guard. Our logic goes here. This should be called enemy. Here we go. So now we have an enemy header file. Cool. And of course the billboard is just a texture 2D. Now I can use texture 2D. So it's now defined in the enemy. And to be fair, this should probably be a struct. So now we have an enemy struct. And the only thing in that struct is a billboard. Oh yeah, coffee, dude. Okay, when we're placing the enemy in the scene, we also need a position for it. So we're going to need a vector3 position. And we know we want to shoot at this target. Also going to need a bounding box. I believe it's like defined in world space. Yeah, world space. You know, this is world space. And that's important because that means that this position will work. Float, let's call it size, and a float height. So with a position, a size, and a height, whenever the player tries to shoot, we could create a bounding box at each enemy location to check for collision. That's how I think it has to be done. I haven't read anything about this. I have not seen a guide on this. This is my assumption. Include enemy. Is this too many includes? I don't know how it's supposed to look. Is this too much? Enemy 01. Variable enemy is not a type name. Boom. No? Enemy is not a type name. What? I'm sorry. Oh, tie us. Type def. Should probably read up on that. C programming language, type def. Alternative name to an existing data type. Can I just go enemy here without the type def? I don't know. Anyway, now we have an enemy. We have the enemy 01. We might need an initializer, of course we will. Again, this should maybe be done in like a world class, but whatever. All the way down here, go void. Too many void functions as well. So here we initialize this enemy. 1, so currently we only have 1, so we're probably going to make an array of enemies and loop through it. But right now, enemy 01 billboard equals load texture, and the file name should be assets billboard. Enemy 01 dot. So where do we want to put this? We could put it at 0, so 0 height, so this isn't used right now, but let's do 2. I haven't seen it yet, so. This initializes our enemy, and now we need to actually draw it in the scene. So here, build level, enemy 01.billboard, and no tint. And nope. There is nothing actually. Let's try again. Oh, okay, so now no billboard. We're back to square one. I know it's not working. I'm an idiot, is why. .png. God, I can't believe it's not even the first time. Here we go. What? No. Does this display? I wonder. Yep, it very much does. So now I have the billboard. It's kind of freaky actually. But so this works. This does not. Why is that? Oh, wait. Okay, so this is where pointers come in. Okay, You're passing the enemy struck by value. Any changes made to enemy are not being applied to the actual instance. Instead, you're modifying a copy of enemy and the changes are lost once the function exits. Yeah, I'm not. You need to pass a pointer to enemy 1 to the init enemy function, so it can modify the actual object and not a copy of it. Object? Modify the init enemy function to accept a pointer to enemy. What? Oh! It's overlapping. But, okay, I don't know what the hell is going on here. Okay, so, I'm back. I made some changes. This is now a pointer, so apparently I'm passing a struct, as you probably know, is a value type. So I'm passing a value, not a reference. Now, because it's not object-oriented, I wasn't really thinking about this, and I'm still not really thinking about it, because this is weird to me. The init enemy now takes a pointer reference. Not sure why I'm screaming that. So we create an enemy, and then we send a reference to this enemy, like so, is what I think is happening. And down here, we take the enemy pointer, right? We take the pointer. And so instead of enemy.billboard, we do this. So we're assigning the value of the enemy which we received. Oh, I need to read about this once more, because I know next to nothing about pointers. Well, I know what they are. I understand the idea behind pointers, but I never use them. And this is my first time writing C code, so this is all new to me. But so far, there are no errors. And it did draw, which is what I want. So let's try this again. Without the duplication. Okay, look at this. We have an enemy billboard. We can shoot at it. It is not destroyed, of course. It's also very large. But yeah, so we had to use pointers, which is cool. I was hoping I would run into pointers. I just wasn't sure when that would happen. In the build level, so this is all happening in 3D space. we're drawing the enemy billboard, and the function for doing so takes a pointer. So this is kind of, we're passing a reference to the enemy 01, which is kind of instantiated then, I suppose. It's not, but it's like we're almost working with objects, but not really. It's a pointer to a memory address that holds a reference to the enemy 01 or something to that effect. Very interesting. I need it to be higher up. I don't even know how large that cube is. Yeah, there we go, look! Yes! This is what we want. So I wanna make it so we can shoot it and it breaks apart. Wow, that's perfect. Perfect sprite placement. So after we implemented the billboard, I thought, hey, let's implement this box texture, you know, off camera, right? It's gonna be super quick. I have the code right here. This is gonna be, you know, 5 minutes max, right? So I set out to do that. So I created the box header file. I've previously created other C files, but they didn't really work, and I thought I was doing something wrong. So I removed them, like I had a weapon.c and a player.c, but I removed them. Now I decided, hey, I'm copying this code, it has to work. So I created box.c, it contains the function for drawing the cube, right? And you can tell, we don't want this in our main program. We do not want this in our main. It's too much code. But as you can see, there are no errors. Everything is fine. Right? There are no warnings, nothing in the box file, nothing in the main. Everything is fine, everything is perfect. But when I run it, it gives me an error. It tells me that the draw cube texture is not defined. And I spent probably an hour looking around thinking, what the hell, what am I doing wrong? I must have checked this signature in the box header and the box C file so many times to make sure that it's correct. And then I remembered that, wait, and I'm drawing the conclusion that this file is not working, just as my previous C files did not work. So I went back and I looked at this unlocking VS Code's power to make games in C, and he mentions that, so in the tasks JSON, this is the build command for the make file. And you can see here that we are basically compiling file base name no extension .c. That is the main.c. So we're not compiling and we're not linking this file. Now I could probably add this as an object. I could add box.c here, but that doesn't fully solve the problem, because what if I want to make more classes? I'll have to go in here and keep adding them all the time. So I'm really hoping that I can just add everything in my folder instead. Okay, I've just spent probably an hour trying to understand how I can compile everything. I went back, I looked at tutorials that didn't work. I eventually found this question asked 9 years and 3 months ago on Stack Overflow. Thank God for Stack Overflow. And you can tell here that he's using a makefile, just as we are, and he ran into this problem, which is exactly the same problem I had. Fatal error, can't create OBJ for his file. So what is happening here is I've moved all of the code down to this folder. There has to be, so according to my makefile, if we go down here, you see we have a source directory and an object directory. All of this is Greek to me. Don't understand really what's happening here. Wildcard and directory, like what is all this? I can't read this. Now that I've been staring at it for a while, I'm starting to be able to understand. We have our source and we have our objects. The path needs to be correct, and you can see here we have the source directory, source, and the object directory. Both of these folders need to be in the project. So all of my code needs to be in source, and this OBJ has to exist because it creates objects. And here's the main application. What's good is, if I try to run, so before if I had to run from main C, but now I can try to run from box C, or we'll see, probably. Yes, and it works. Now I can play, everything is visible, everything's working. You can see the box just works by itself now. Might actually even be able to try and debug the tasks JSON. Yep, and the game still runs. So it doesn't matter what I'm selected on, I can do whatever changes I want. Oh, that took a while. So, again, welcome back. Now I can make whatever files I want. They have to be under source. So our box C now holds a function called draw cube texture. I haven't even had time to look at this correctly because I was running into so many errors. You probably recognize this, grabbing the vertices and the faces and the normals, texture coordinate stuff. Really boring stuff. We don't care about this. We care about drawing our cube in the build level. So here, draw cube texture. Now I can call this with a texture and a position, and it's going to create that box for me. And the definition for this function is in the box C file, not in main, which is why it's something I've been wanting this entire time, and I just haven't been able to get it to work because I needed to find the tasks and the launch and the make file, and it wasn't clear how to set this up, and I've never really done this before, so maybe I'm just a huge noob, but I haven't done this before. Usually I create my projects straight in VS Code or Visual Studio and it just works out the box. I'm not used to this stuff. But I can start removing things from the main function to clean it up. So far we have box, that really is a bad name, the enemy struck, the player struck, the weapon struck, so it's starting to kind of come together. And again, if I play, we now have a small level. I also, instead of a box, this is now a plane, much better. And we have our enemy and we have our boxes. So these boxes are all gonna go. We will be using these ones. Oh, I didn't, wait, I haven't seen that before. That's an interesting phenomena. Is that because of the billboard? It is. Look at the billboard blocking. Well, that's interesting. There's a lot left to do. But now I finally set up the dev environment correctly. This is something that I was supposed to have done in the beginning. It's finally set up now. Now everything is working as I had hoped. Cool. I'm just gonna go back and work on this off camera because it stresses me out a little to have the recording going while nothing is happening, right? I just sat here for an hour looking at the make file. Not an hour, but you know. So I'm back again. I've been going at it for a while, and now we have these 5 enemies spawned into the scene. These enemies are randomly placed, so every time I start the game, they're in a different position, a different configuration. So they're never quite in the same position. They have a range of about 20 units, I believe. Yeah, so they have a range of 20 in X or Z, but the Y position is locked. So we're drawing a textured cube with an enemy on top, and what you see here is their bounding box. So I'm now spawning in the bounding box, or not really spawning it, I guess. I'm just drawing the box as it is, and it belongs to the enemy. So we can't shoot it yet, but it's there. If we take a look, main is still a mess. But the enemy class now holds this initialize enemy function. And this is probably the most good looking code I've done so far. The goodest looking. If you compare this to the shitstorm that is the main function, this looks pretty neat. So the texture is now a billboard sheet. So it's a sprite sheet. I'm gonna show that in a second. Or I probably already showed it, I'm not sure. We'll see when I'm editing. We can set a manual position. This is how we randomize it. They have a size, they have a height, and here we have a sprite width and a sprite index that aren't quite set yet. Here you can see the hitbox. So how this works is, we have an array of 5 enemies and an array of 5 enemy positions. So when we initialize, we randomize an X and a Y value with a range of 20, as you can see. We set the position and then we initialize the enemy onto that position. And if we jump down to the enemy function, so the position is received here, the position is set. That's it. That's all it does. And then down here in the rendering, here we see the build level function, and we're now looping through the array of enemies. Now, this is hard-coded to 5, and you might have noticed the array was also. That's because I can't assign a variable to the length because the compiler yells at me. I could maybe do a define length, I'm not sure. Right now I'm just hard-coding 5 here. This is bad practice, of course. And you can't get the length. So the array is 5, that's fine. The reason I'm looping to a hard-coded value of 5 as well, why I'm using magic numbers here, is because I can't read the length from an array. You're not allowed to read the length of an array. There seems to be some workaround, but I just wrote 5. It's fine. It's fine. We're now rendering with the draw billboard pro function. This is a bit more complicated. It demands a bit more code. We have to define a rectangle. I did the same for the weapon. You need to use this when you want to animate. So we set a bunch of values like the billboard, the rectangle source, which is basically which part of the sprite sheet that we want to show. So here's the billboard sheet. You probably saw me make this. I'm probably going to do a small time lapse. So each sprite here is 128 wide. The rectangle defines this entire position. Basically, it defines the size of one of these sprites separately. So we're creating a rectangle as a selector for which sprite from the sheet we want to show, and then we're drawing that billboard. And right now, and the sprite we show is the sprite index on the enemy class. You can see that the sprite index is by default set to 0. So all the enemies are showing the first sprite. All of our enemies are showing this part. If I set this to some other value, we'll see one of these other results. We then draw the textured cube on the enemy's position, except with a 0 value, so it's right beneath them. And yeah, that's pretty much the difference. Kind of slowing down my pace here. I need to, untangle this entire spaghetti that I'm looking at right here. So I have some more work to do. I'll hack away at it. So, my 48 hours are up. This is the result. We have enemies, we have a bunch of cubes as our level. Now it's looking kinda terrible, honestly, but the enemies are randomly placed. We can shoot, but we can't hit them yet. We can only hit this black wireframe in the middle. We can jump, we can move around, but we can't do much else. We can't actually interact with the world. We can't get hurt, we can't kill these enemies. It's Sunday morning. I wanted to use these last few hours to clean everything up and get to work on some more logic, right? To add more to our game. Immediately as I started, the compiler was just fighting me. So I've tried to get these values to stay here on the weapon script. At the same time, I'm trying to refactor the main, and I did. I removed a bunch of logic to like the weapon class, tried moving it to the player class, and it was just fighting me all the way. Yeah, my 48 hours are up. This is still spaghetti. Still have not implemented the logic that I was hoping for. Of course, I haven't been working for 48 hours. I've only been working for, I have plenty of other commitments. I am old. I can't just sit in front of the computer for 48 hours. That doesn't work. I have other things to do. But the weekend is drawing to a close. My hours are up. This is what I came up with. And honestly, I think half the time has been spent fighting the compiler. Not understanding the error messages. Clearly, I'm just not used to the language or the compiler. These results are not satisfactory. I want to implement shooting the enemies and seeing them break. When that's done, then I'm satisfied. Anyway, I'm gonna keep chipping away on my own time outside of the 48 hours until it's done. So here's what I've been doing, right? So I'm setting up a ray, I'm creating an empty collision, I'm setting up a ray from the center of the screen, and I check if this ray hits the box, right? So this is the bounding box in the middle of the world. So now I want to check against all of the enemy collisions. So you can run a maximum of 5 times. It breaks when we hit something. So if we haven't hit something yet, then we'll just keep checking with the same collision. Ray collision. But now we're checking against enemies hitbox. Is it that easy? Wait, this seems too easy. We check against the first box. If we hit it, then this is true and we break out and we set the line endpoint. Otherwise, we set the collision to the first enemy. The next time the loop starts, we break. Can I make something obvious here to show myself that this has actually happened? I could set a flag of some kind. Okay, we're just gonna see if we can tell. So for example, if I shoot here, sometimes a long ray, sometimes an incredibly short ray. If I shoot the central box, the ray stops. That's important. It stops at the box's surface. That's how I know that it's working. It never goes through this box, but it can go through other boxes. So if I shoot here, it penetrates, right? So now we'll check against all of the enemies. Yeah. Look, it stops. So I'll shoot here. Damn it. I need to make this more clear. So I could go enemy's eye, because I know which enemy it is. I could change something. I could change some property on the enemy. Yeah, wait, I'm an idiot. Sprite index ++. I'll increase the index of their sprites. So each time I hit them, the sprite should change. Let's try it. So, wait, it's moving. I'm hitting it. Missing, hit. It's not doing what I was hoping. Oh yeah, of course, I'm a dummy. The sprite index is the width of the sprite. Ah, Jesus. So plus equals sprite width. I need to offset it by 128. I was moving it 1 pixel. Yeah, look at that. Look at that. Boom. The only thing that's left is the stick. So I'll add a boolean to the structure called isHit. And then here, go underscore enemy hit equals false. So we'll initialize the enemy as not have been hit, obviously. But when I hit the enemy, enemy's index equals true. So that's good. That's good. So we don't actually want to manually change their sprite. Obviously, we want to just say that they're hit and then we want to start a function to loop through their sprites. Draw billboard pro. Yeah, here we go. So here we're drawing all the enemies. We're drawing the billboard for the enemy. We're drawing the bounding box for their hitbox. And we're drawing the cube that they're standing on. So here we could go. If enemies is hit, this is false. Draw the bounding box. So we're not drawing the bounding box if they haven't been hit. If they have been hit, sorry. Okay, so I'll add another conditional here. This is not pretty, but enemies. So if we're about to calculate the ray against an enemy that has already been hit, then we just continue. Let's see if that works. So I shoot this enemy. Yeah, the bounding box is no more, and I can't shoot them. Nice. I also want to check against all of the boxes in the scene, but that'll have to wait. This needs to change. This has to start some process for going through all of the enemy's sprites. And also this needs to happen every frame. The enemy has to be able to cycle through its own... It needs to be able to cycle through its own stuff. So I created a prototype here called cycle enemy animation. It takes an enemy as a pointer. So we're doing void cycle enemy animation. Does it still work? Because sometimes it crashes for basically no reason. Okay. Oh. Can still hit the enemies. So this, the enemy, I'll need a timer. Animation time. So cycle enemy animation will be called from main here. So when I hit one, cycle enemy animation, enemies eye. Right, and this needs to be a pointer. So when I'm sending it, I think I need to do like that, right? So I'm sending the memory address of this particular enemy. So I'm pointing to this enemy in the array. I'm hoping that works. Plus equals enemy sprite width. If this works, every frame it should switch its sprite after I've hit it. So this should look crazy. It should just be flashing basically. Yeah, exactly. And it's happening for every enemy that gets hit. So the logic is sound, but I need this to happen not all the time. I spent some more time working on the animation here. It ends up looking like this. So when an enemy is hit, we start this cycle enemy animation function. This is run from main, every frame for all enemies who are hit but not yet dead. Their animation time, which defaults to 0.2, is slowly reduced each frame, so each 0.2 seconds the timer runs out. And when that happens, we increase the sprite index, causing the sprite to display the next sprite in the sheet. It then resets the timer back to 0.2, so this can happen again. Lastly, we check if we have reached the last sprite in the sheet, and if we have, we set the isDead flag to true, which stops the main from calling this function. Actually, wait, hang on. Let's define max enemies 5, because I'm tired of writing 5 everywhere. Can I do that now? Yes. Okay, so max enemies is 5. Now we set the array to max enemies, and we set the starting enemy positions to 5. And instead of enemies killed, let's do enemies remaining is also max enemies. Here we go. And then in our loop, we go max enemies. So now it's going to instantiate any number of enemies. Oh, that's so much better. Same here, it's not 5, it's max enemies. And here we draw the sprites. Gotta make sure that that's also max enemies. Just gotta make sure I'm not missing a 5 somewhere. Yeah, here we go, enemies. Okay, I think that's all magic number of 5 taken care of. Now we're also gonna copy this stuff. Hang on. Constant char enemies remaining. I'm not sure how this is supposed to be formatted. Enemies remaining text. Position X. And I'll have to go even lower, so we'll go 120. So now we're drawing the text on the screen. Let's see what happens. Enemies remaining, colon, nothing. I'm not entirely sure what this formatting is. Let's also try set max enemies to 50. Oh shit, here we go. 50 enemies. Does that just work? Yeah, it does. That works. There are now 50 enemies here. Oh. And the collision is sometimes funny. I'll hit an enemy behind. That's interesting. Not entirely sure what that happens. Is that because of the draw order? I'm not sure. Oh, of course, I'm checking them. Yeah, the order in which I loop through the enemies. So here, in the collision, we loop through all of the enemies one by one. I might very well be checking the one that's further away first. We should also do or enemies is dead. Yeah, so we're not drawing them, and we're also not checking for the collision against them. That's good. Oh, hang on. Percentage D. Yeah, enemies remaining 50. And now, finally, after much toil, everything works. Text being displayed, enemies being hit. It was a long road, from trying to get VS Code even working, questioning what CMake even is, to many hours of writing C for the very first time. Am I happy with the result? Yes. Sure, I hope it could have been more, and I actually thought when I started that I would make a little Pong game perhaps, and then attempt some platformer game maybe. You know, to dive headfirst and create an FPS shooter, that's never a good idea. But it kinda worked out anyway. Would I do this again, or suggest anyone else to try it? Absolutely. This was an incredible learning experience. Just pushing myself a little for a weekend, and suddenly I know so much more. If you're feeling cozy, using the same game engine all the time, wondering what else is out there, challenge yourself to create a project in a different environment. I had a lot of fun. Anyway, if you made it all the way here, thank you so much for watching. I hope it was interesting and not too long. I wish you happy coding and good luck on your next project.